Hey ChemExcel, this video introduces the Making, Altering, and Equilibrium System virtual lab that you guys are going to be doing. So this helps put it in context of what you learned last week and then like what's going on in that lab. Okay. So first of all, just kind of going over what we know so far. All right, from your Equilibrium Beakers lab, which looks like they've been going very well. It's awesome. Thank you guys for the effort you put into that. We found out that at equilibrium, the forward and reverse rates of reaction are equal to one another, but the amounts of the reactants and products are not necessarily going to be equal. All right, so these graphs over here kind of show that. Right, this shows that the reverse rate, so I'm pointing something out, is starting at 0 because if all you do is dump reactants into a container to begin with, then you have no products for the reverse reaction to run with, and so the reverse rate would start at 0. The forward rate, would start quickly, all right, and then as you use up some reactants, the forward rate, we can see the forward rate slowing down here, while the reverse rate speeds up until they hit the same rate as one another. Okay. But we can see that the amounts, those don't necessarily have to be equal, and generally speaking, they're not. It's actually pretty rare for them to be equal at equilibrium. So in your Beakers lab, this was the point right here where these are intersecting, where the amounts are equal, and that was that first image you took in the Beakers lab saying like, oh, well, most people probably think it's at equilibrium because we have the same amount of reactants and products. But then when you kept scooping, you found out that that continued to change. All right, you may have ended up with more products than reactants, or vice versa. It just kind of depends on which scoopers you were using for those. All right, but that's equilibrium in a nutshell. It's about equal rates of the forward and reverse reaction. So you're making products at the same rate as what you're using products to reform reactants, and it's going to look like nothing is happening at the macroscopic level. It's the part here where no change in the amounts. In the lab, we're going to make an equilibrium system, and then we're going to alter it. A couple important things. The system has to adjust itself to reestablish equilibrium. So once it's at equilibrium, it's not that a small change just suddenly makes it spontaneous or suddenly makes it non-spontaneous. It will have to reestablish an equilibrium. And at the new equilibrium, those rates will be equal again. But a disturbance is something that will cause the rates of the forward and reverse reactions to be different for a moment. But they are going to come back together and meet at the same rate eventually, right? Usually pretty quickly. The purpose of the lab is to determine the rules that are used by the system to help reestablish equilibrium. So how does the system get back to equilibrium if more of one of the components is added, or if a component of the system is removed? How does the system respond? So we're looking for two overarching rules on that. This is a little example of a graph. We can see that this system is at equilibrium because none of these concentrations are changing. They're all plateaus. But then we see right here, the concentration of H2 has spiked, which means somebody must have added more H2 to the system. And then the question is, okay, now that that's happened, what's going to happen to the rates of reaction? What's going to happen to the amounts of things? All right. But first, we'll just get to the overarching rules. Okay. So the flow of the lab is that you're going to open the virtual lab, watch the system get set up, and then you're going to be given a couple of goals. You're going to be clicking on different things as you go through it. You navigate the whole thing by clicking on certain things on the slides. All right, once you're ready to move on to something, and some slides you make choices about what you are going to be clicking on. Do not worry if you feel like you are guessing early on. All right, this lab is like an exploration, so you might feel like the first thing you click on is a guess. Okay, well, if you guessed wrong, you're going to find that out, and then that'll help start guiding you to what the correct answer is. As you go through, it becomes a little bit more obvious. All right, so it'll be okay, even if you start off feeling like you're guessing. Again, ultimate goal, two overarching rules. All right, rule 1, what does the system do when something is added? Rule 2, what does it do if something is removed? This is the system that you're going to be seeing in the lab and messing with. So this would be something you would normally do in the classroom. Sorry, we can't actually do that. All right, but if we start off with these two colorless solutions, All right, this one's technically slightly rusty color, but it doesn't really impact anything. You can't see it very well in the video either. All right, when you mix these two solutions together, you're going to get a double replacement reaction. It is exothermic in the forward direction. All right, and one of the products is actually going to be this red compound, iron 3 thiocyanate. Okay. It is an equilibrium system because if you were to have just gotten a hold of the iron 3 thiocyanate and some potassium nitrate and you were to mix those solutions together, this endothermic, or thinking of it as exothermic in reverse, right, this reaction would happen. You would form these things that were the reactants on the previous slide. So both of these reactions do occur, and they will create an equilibrium system by occurring at the same time. So whatever you're going to call reactants, we're going to use these as our reactants just because that's how it's written and that's what I had access to in the lab to mix together. All right. Once we mix either these two, or if we were to mix these two, it would establish this whole system, and all four of these components will be in that system. All right. The reactants making products, the products remaking reactants. Right, in the lab, what we're looking for is color changes. All right, so the fact that one of the products is red is really important here because we can tell how much of it is present by looking at how red it is. So we can see color changes to get to a darker red or a lighter red. Darker red means we've created more of this substance. Lighter red means some of it has been used up. Okay. And then again, ultimate goal, we want to know how does the system respond if we add a component, and how does the system respond when we remove a component. All right, and we'll be looking for those color changes to let us know, has it shifted towards the reactants or has it shifted towards the products. So the next step here is you're going to open the Google Slides presentation, making and altering an equilibrium system. You need to make sure that you click present. Okay, oh, sorry, things shifted when I changed the background. So present here. You need to click that because you're not going to be able to navigate around the slides properly. If you're just reading through the slides, that's not going to work. So do make sure that you click on present for this lab.